IR data as well?
Aldehyde?
This is your signal A. That's your signal A. Aldehyde hydrogens are around between 9 and 10 in that part of the spectrum, and it's integrating for one hydrogen, and of course in this case it's a triplet, and obviously IR very distinctly tells us there is an aldehyde in this molecule. Everybody with me?
Mm-hmm.
Let's take all of this and put it together. So what do we know so far? Looking at all the data we have. A, we know we have an aldehyde, right?
Yep.
B, we know we have a mono-substituted benzene, 5 hydrogens. Yes? We have also a CH2 somewhere because of the signal B. We also know that signal A is bonded to signal B. So if we put these together, our other clue is that we have a CH2C. Make sense?
Mm-hmm. Yeah.
How many carbons have we used up so far? 6, 7, 8. Isn't that right?
Yeah.
How many hydrogens have we used up so far? 1, 2, 3, 4, 5, 6, 7, 8. How many oxygens have we used up so far?
1.
Is that the chemical formula of the compound?
Yeah.
How many IHDs have we used up? We calculated 5. We need to make sure we are using them all. How many IHDs here?
4.
4. 1, 2, 3, and the ring. 4. And
5.
done. Used. Everybody okay so far? So what do we have at this point? We have this piece and this piece. How do I take these two pieces and put them together and create a molecule?
The CH
Suggestions?
The CH2 bonds to the benzene.
So what is the structure of this compound? The structure of this compound basically is that, yep, you got a mono-substituted benzene connected to CH2, which is then connected to an aldehyde. That's your compound, which satisfies the proton NMR, which also satisfies the IR data. It aligns with all of that data. Assign your signals. Okay? Basically, this is the question you were asking earlier, Dash, about those two. Where is my red? I need to clean this table. I really do. Okay, so let's call this, which one is that? A or B or C or D or E?
A.
Do we all agree? Where is B? Do you all agree?
Yep.
Now, where is C and D and E? So, here, exactly, but we can be a little bit more clear here. So do you see this signal right here, which was kind of separate, the one integrating for 2 hydrogens? These are these two. Whether you call it C or D or E, who cares? But those 2 hydrogens that are on the 2 positions either side of the CH2 are equivalent to each other. Isn't that right? And then what about the ones integrating for 3 hydrogens, which is what you were asking? Well, these 3 are not identical, but they end up being extremely, extremely close to each other, so their signals just merge with each other. So the reason we got 3 hydrogens here is because there are the 2 hydrogens and the 1 showing up together. And does that make sense, everybody?
Yeah.
Yes? Isn't this fun? It's like a puzzle solving. The clue, the trick here is there's no one thing you can do, because it's like solving a puzzle where you have to try this and try this and try this and see how best it fits. But the clue is, the trick is gather all the clues and then try and put them together. Yes.
So for the benzene, like, with the most unshielded ones are more downfield, right?
Which ones are the most unshielded ones? or de-shielded ones?
Yeah, these the ones
These
that clump
two?
together.
These two? Yeah, right,
Yeah.
and based on the spectrum, yes, we can expect that these are the more downfield.
Right.
Yeah,
Okay.
is that the question?
Yeah.
Yeah, absolutely. Okay, let's do the next one, please. Okay, let's start with the top one first. IHTs. First, there's no ion here, this is all based on protons, so IHT first. 4, so what did we say? Whenever your IHT is 4 or above, what do we
There's
do?
a benzene.
We think about it, no, so there could be a benzene, right? And then where do you go to confirm whether there is or not? Then we confirm based on the spectrum. So did we say IHT was 4, is that correct?
Yeah.
Okay, so yes, we should think about, oh, could there be benzene? And then how do we confirm? We look in this part of the proton spectrum. If there are signals in this part of the proton spectrum, then yes, there is a benzene. If there were no signals in this part of the spectrum, then no, there is no benzene. You have to figure out a different way to account for those 4 IHTs. Sounds okay? Mm-hmm. In this case, what do you think? Is there a benzene or not?
Yes. There's a benzene.
How many signals? 2. Are you sure?
3 signals.
I'm seeing 3.
3.
So I'm just going to go left to right. This is A, B, C.
Oh, yeah, right.
Agreed?
Yeah.
Of course, that's TMS, we ignore. 0 is TMS, we ignore. So 3 signals, meaning 3 kinds of hydrogens. Let's measure the integrations. So A is to B is to C. Okay, let's see what this is. So this guy, about 13, about 13 as well, and then 1, 2, right? 20.
Yeah.
Oh wow, okay. There's definitely something there. Okay. 30 and 20. Now, remember, always take the integration measurements with a little flexibility, because that's really a user thing. When you do NMR in lab, you will use your skills to come up with those integration curves when we use the instrument. So that's really a user thing, and users can make mistakes. So therefore, that is the reason why when you see those numbers, always be willing to, fudge them a little bit towards something that makes sense. That's important. Okay, so if we have 13, 13, 20, and notice we have 7 total hydrogens, how does that make sense?
We have a 1-to-1 there.
So 13, 13, and then what would that be? 20, oh 20, so not 20, what would that be then? You're right, this is 1-to-1, but then what would that be? How do we figure that out, guys? What is 20 divided by 13? Little bit of math.
1.54.
1.5,
Yeah,
Okay.
1.5.
everybody okay? Right? What is 1 plus 1 plus 1.5? But we have 7 hydrogens. So what is the logical conclusion? Yeah.
Multiply by
So
4.
So what is the logical conclusion? This is for 2 hydrogens. This is for, and do you see what we are doing here? What is 2 plus 2 plus 3? 7. We have 7 hydrogens. We okay, everybody? Now also when you see 3 hydrogens, homotopic 3 hydrogens, what does that most likely indicate?
1 signal.
No, yes. What group does that point towards?
Methyl, a CH3.
Everybody okay? Cool. Now let's look at multiplicity, because in this scenario, multiplicity is extremely helpful, very helpful in this example. So if we look at multiplicities